Hello, Alex? Can you hear me? Oh, hi. um, I don't know if you've seen my other video about composite functions and differentiating them. Um, you haven't? Okay. Well, I suggest you do definitely go and see it. But your persistence on me doing a three function composite function is I thought it was coming from that video because at the end of the video, I promise that I'm going to do a number of functions involved in the composite functions, and then a longer chain. So you haven't seen it, so I suggest you go and see it. Yeah, yeah, it's just from my blog. Yeah, don't put your video on because I'm actually videoing this session. Hmm. Yeah. And as a punishment, as a as a punishment, when I finish this session, I want you to do a, a more maybe four functions involved in the composite function. Okay, so let's start. So I've already prepared this. It's a three function composite function, and as you may know, that I like to write it like this. So it's H, which working on is operating on G, which itself is operating on f of x. So the variable of x is being worked on by f, which would have an output, and then that output becomes the variable for g, and then g operating on that output will have a result and an output, and then that result or output becomes the variable or the input of h, which will then have an output. So we want to differentiate this. So let's say y is equal to this, and essentially we want at the end of this exercise, we want to find dy dx. So as you remember, or you may remember because you haven't seen my other video yet, but I go through a number of substitution, and through those substitutions, we will then use the chain rule to find the final differential. So I would substitute for fx, so I make a new heading or a new variable, which is u. So u is going to be substituted in place of fx, and hence g will then become g of u. So I'm gonna substitute for that as well. So we're gonna make another heading w, and that would be replacing g of u. It would be replacing g of u, and then we will then have y, which would be equal to h of w, because we are replacing g of u for w, so it becomes h of w. So we've got three steps here, and we're going to differentiate each step, which then hopefully chain through to give us the output that we want. So for this one, let's just use a different color. Yeah. Let me finish this one. We'll stop the video and then we'll work on that. So du dx is equal to f dash x. So basically, the differential of f, which is an expression in x, and I'm assuming that if it's a very straightforward expression in x, you can differentiate it. And then we have dw, so this is differential of w, but it would be with respect to u, because the variable of g at this stage, the variable of g is u, so therefore we're differentiating the subject with reference to the variable, which is the u in this case. And that will simply be g dash of u. And then finally, we've got dy. Dy what? What's the variable here? Yeah, dy dw, so with respect with w, and that would be h dash w. So through a chaining effect, we're going to eventually find dy dx. So I'm going to show you the chain. The chain will begin with du dx, which is multiplied by dw du, which is going to be multiplied by dy dw, and through chaining effect, so that cancels with that, that cancels with that, and that will leave us the dy dx that we wanted. So if we put these together nicely, you can see that dy dx is equal to, so I'm just going to write it on a fresh line, so it'll be dy dx is going to be equal to, so let's move this along as we see, so it's going to be that, which of course is that, so it's going to be f dash x, yeah, and then it's going to be times, it's going to be times by that, which is of course that, so it's going to be times by that, and that will be times by g dash, but g dash of u, and u is fx, so g dash of fx, and then multiplied by, so the next round is that, which is that, so it's going to be multiplied by, let's put a little dot here to make sure that we know the multiplication is happening, so it was going to be a h dash of w. Now w is gw, and w is gu, and u is fx, so it's going to be h dash of w. Now w is gu, so it's going to be a g, and then u is fx. And that's it. So I think as a confirmation of you understanding what went on, I think you should do a 4-function composite function and differentiate that. But I think you can see what will happen. So it'll be a f dash x, and then will be a g dash of fx, and then if it's at a third level, you would have that as well, and then the fourth one, whatever it is, will have so this is a double composite function, so inside the last one would be a treble composite function. Okay, so I look forward to seeing that soon, and now you can ask me, so let me stop this video and then you can ask me your next question.